So here we are in lesson number 7 in the Foundations of Algebra course. So we're working on the operations. We've seen that there are not 4, but only 2 operations, addition and multiplication. And a couple lessons back, we took care of addition, and then we dove into multiplication. This lesson will continue that exploration of multiplication. So let's get right to it. In terms of multiplication today, we really have 2 new things. I don't know that they're new. I think you've seen it before, but I want to make sure everyone's on the same page, and then we'll extend it a little bit. Exponents. Exponents, as you probably know, are the notation that we use for repeated multiplication. It's very simple. So if you have 5 to the third, you guys know that that just means 5 times 5 times 5, 3 5s multiplied. And that just gives us 125. Nothing to it. All right, so it's a space saver. It's a really cool notation for that repeated multiplication. It works the same for other types of numbers like integers. -2 to the third is -2 times -2 times -2. Same way. And that just equals, by the way, -8, right? Because -2 times -2 is positive, 4, positive, times -2, so 4 times -2 is -8. So it's following the rules that we went over in our last video. If you have -2 to the 4th power, okay, well, it's just 4 -2's laid out. And now the sign of the answer, can you guys see? Good. Yeah, it's going to be positive, right? Because we got -2 times -2, that's 4, times -2 is -8, times one more -2, that's positive 16. In fact, any even number exponent of a negative is going to end up being positive. I think you can probably see that. And that's just 16, by the way, positive 16. Fractions, exactly the same. Multiply them out and then straight across. So 3 times 3 times 3, or 3 cubed is 27, and 4 cubed is 64. All right? Oh, this is kind of neat, and this will help us later too. 10 to the 5th, okay, no big deal. You understand, it's just 10 times itself 5 times, but that just ends up being 100,000. And in fact, the number 5 in the exponent there, that really just tells you how many zeros you end up with, all right, in the final answer. Look at that. So, all right, for later, just keep that in the back of your mind. All right, now here's a very cool extension. I'm not sure if everyone's seen this already, maybe, but it's worth just making sure. We know how to handle, exponents like 2 or 3 or 4, but how about something like this, like 5 to the 0 power? Or even stranger on the surface, how about like 5 to the -2? Well, that's got to be a little different, right? We can't write out 5's -2 times, 5 times 5 times 5, -2 times. That seems weird. And we don't do that, okay? In fact, this is extending it. This is just mathematicians sort of pushing it a little bit, and we're going to make a definition here to make sense of both of these weird exponent situations. It turns out that any real number raised to the 0 power, except 0 itself, okay? But we'll call that real number A. So any real number except 0 to the 0 power is always 1. It's always 1. So for example, 17 to the 0 power, that's 1. 2.3 to the 0 power, that's 1. 5/8 to the 0 power, that equals 1. All right, piece of cake. The negative exponents, like this. So again, any real number except 0 to the -n power, it just ends up as 1 over a to the n. So a to the -n equals 1 over a to the n, okay? So the negative exponent really results in this reciprocal thing. Here are a couple examples. So if you had 4 to the -3 power, that's the same as 1 over 4 to the 3 power. And 2 to the -5, well, that's just 1 over 2 to the +5. All right? Maybe we'll have some time in the future to make sense of why each of those facts is what it is. But for right now, you just got to know those facts moving forward. A related issue to this is roots. Okay, roots are actually related to exponents, believe it or not. And just to make sure everyone's on the same page, there's an example I'm sure you guys have talked about before, but this is the square root of 9. And remember that when you see that represents the number that when you multiply it by itself 2 times, or in other words, when you square it, okay, there's the name connection. So square root of 9 is the number that when you square it gives you 9. And who's that? Well, that's just 3, right? Since 3 times 3, or 3 squared, will give you 9. All right, that's how square roots work. Nothing to it. But we can extend it. We can talk about the cube root, or third root of a number. And the third root of 8, the cube root of 8, well, what do you think? That little number in there, that little index, that tells you how many times we're going to multiply that number by itself to get 8, right? So what number are we looking at there? Who do you have to cube to get 8? If you try some numbers, you get to 2 pretty quickly, right? Since 2 times 2 times 2, or 2 cubed, does in fact give you what you see under the root. It gives you 8, all right? Like we can keep going. We can do 5th roots of a number, 6th roots of a number, okay? You just go as far as you want. By the way, 2 and 10, all right, for both those values. But what if the root isn't so nice? Sometimes you got to estimate what the value of a root is. We've already seen this when we dabbled in the irrational numbers earlier in the course. But like, for example, the square root of 17. If you needed to give a good estimate of the square root of 17, well, what it amounts to is you have to figure out what number, or what number, close to, is going to be, when you square it, will give you 17. All right. Now there is an exact number, and we call it square root of 17, but now we're going to estimate it. So wait, is it 4, do you think? Yeah, no, I don't think so either. I think you're right, because 4 times 4 equals 16, not 17. So 4 squared is 16. Ooh, we just missed, right? We just missed. So let's go up a little bit. If we go to 5, though, that's no good, because 5 squared gives you 25. We're only looking for 17. So does it make sense to you to see, or to say that probably the value is probably closer to 4 than it is to 5, right? Because we only want to get 17, and 17 is extremely close to 16. So the square root should be really close to 4, but a little higher, maybe like 4.1. Does that sound reasonable to you guys? Okay. So tell you what, if you had to put square root of 17 on the number line, we can do it, right? Since we know it's about 4.1, a little bit more than 4. Here's a number line. Let's find 4. You can see it's definitely between 4 and 5. We said that, but it's way closer to 4 than it is to 5. So it's to the left of 4.5. In fact, it's hugging 4 there, just a little bit bigger, right? We'll drop it right in there. There's an exact spot where square root of 17 lives on the number line, okay? And there's our decent estimate of placing it. All right, here, let me give you one to try on this extension. Let's try to estimate the cube root of 25. Now, if you want, you can pause the video, give it a shot, come back and check your work. If you want to just keep flowing, I leave it up to you. I'll be here either way. Okay, let's take a look. The cube root of 25. So remember what we're looking for. We're looking for the number that you cube or multiply by itself 3 times to get 25. That doesn't seem like that's a nice number, nice whole number, or even a nice fraction. So what we need to do is estimate. Let's estimate this. Well, let's try some numbers. No, it's not 1, right? Because 1 cubed is 1. 2 cubed is 8. All right, 2 times 2 times 2 is 8. All right, that's way too small. Remember, we're trying to get 25, so 2 is too small. How about 3? So 3 cubed is 27. Ooh, that's close. That's close. And in fact, 27 is more than 25, so the cube root of 25 is probably just a little bit under 3. Okay? See how close we got to 25 by cubing 3? 3 times 3 times 3. All right, so I think I'm willing to say that it's very close to 3, but just a little less than 3. So I want to call it 2.9. And again, if we had to put that on the number line, we could put it just to the left of 3. It's just under 3 right there. Looking okay? All right. There is something that I got to warn you about. This is important. You can run into trouble with roots. And there's one big trouble spot. Take a look at this. The square root of -9. The square root of -9. Well, all right, we're looking for the number that you multiply by itself to get -9, right? So here's a visual. So we're looking for the real number that will fit in there, in that box. I'll tell you what, you might be thinking, I kind of heard some rumblings back there in the far right. No, my right. The 3 is a reasonable guess, right? Is it 3? No, it's not 3, because 3 times 3 doesn't give you -9, it gives you +9. And the only other reasonable number, yes, good, I saw you hold that up on your fingers. I don't know how you did the negative sign, -3. How about -3 times -3? Does that give us -9? No, it doesn't. It gives us 9, right? In fact, there is no real number that will work in those boxes. There's not a real number that you multiply by itself to get -9. In fact, there's no real number that you square to get negative anything, right? Real numbers, a positive times a positive is positive, and a negative times a negative is also positive. So you're never going to get a negative. Yeah, all right, so we got a big problem on our hands, don't we? In fact, that problem extends to any even root. The square root, like we see here. By the way, I don't know if you guys know this, but there's actually a little 2 here that nobody ever writes, just out of laziness because it's so common. But any even root, and now you might see why we're calling it an even root. The square root, the 4th root, the 6th root, and the 8th root. Anytime you have a negative number under an even root, that is not a real number, and we're in trouble, okay? So watch out for that. Just in contrast, let me just point out, if you have an odd root with a negative under there, we're actually fine. So the cube root of -8, remember what we're looking at. We're looking at the number that you cube or multiply by itself 3 times to get -8. And this time, because it's an odd number of factors, this time the -2 gets us where we want to go, doesn't it? -2 times -2, that's 4, times another -2 gives us negative, which we needed, 8. So odd roots, they're all good. You don't have to worry about a negative under there. Odd roots, odd roots are all good. All right, cube root of -8 is -2. All right, here, just to pull all this together, take a look at this problem. Out of those 5 numbers that we see, which of them are not real numbers? Let's circle the ones that are not real numbers. And just remember, the key thing is, when do we run into trouble? When we have an even root with a negative inside it, a negative underneath. Do you see any of those? Scan those 5 numbers. Just scream them out if you hear them. There is no 37 on that list. I don't know who's saying that. Okay. Good, good. The 4th root of -16, that's an even, 4 is an even number, even root with a negative number inside, that is not a real number. That would be a problem for us. Any other ones? Good. Yep, square root of negative 17. Remember, there's that little 2, so it is an even root. The square root is an even root. That's not a real number either. The other guys, they're fine. They're all good. Odd roots, you never have to worry about. Okay? All right, I think we'll call it a lesson for this lesson, and you guys can go to work on this and practice it up, get it super sharp. It's a pleasure, and I'll catch you back in lesson number 8. Take care, guys.